Since we've talked about what science is, now we want to talk about how it improves or how we move forward in science. So here's what scientific progression usually, or how we have decided scientific progression works. And so these words will have very specific meaning, and we'll talk about them here. So in science, we go from hypothesis to theory to law. And a hypothesis is a testable prediction. If it's just a guess and there's no way to test it, it's not a hypothesis. So a hypothesis would be something like, I think that this ball will fall because it's, like this ball will fall to the earth because the earth is there. That is testable because we could go somewhere away from the earth and we could let go of the ball and see whether it falls or not. That's a bit abstract, but maybe something better would be that I think that people get sick because they eat a spoonful of sugar every day for a week, right? You can test that. You can have some people eat a spoonful of sugar every day for a week and another group of people not do that. And then, depending on what you see, you can test it. A theory is a rigorously studied hypothesis that still holds true. So once we've tested that hypothesis over and over and over and over again in different contexts, we've tried to prove it wrong, and that's an important thing, is we've tried to prove the hypothesis wrong, and we're still seeing that it's holding true, then we kind of upgrade it to a theory. So a theory means we are very confident, and this is a place where science words and kind of colloquial English words diverge. In kind of everyday language, if you say a theory, that just means kind of hypothesis and theory are kind of the same thing, meaning a guess or an idea that kind of explains some things. That is not what we're meaning when we're talking about it in science. In science, we mean that we're very confident in this. And so it's something that we've tested a lot and we've found that it still holds true. We've tried to disprove it, and and we can't disprove it. And then a law is a rigorously studied theory that can be proven true for all circumstances. That asterisk in there is because some laws only apply to certain circumstances. So they're saying all circumstances in this situation. So for example, in chemistry, you might have heard of the ideal gas law, and that is true for all ideal gases in all circumstances. So a law will usually be something that has theoretical work behind it, right? There's some mechanism about the universe that we understand, and we've said this aligns with our law, and we've tested it. We've tested all the circumstances and things that we've been able to possibly test, and it is proven true for those. And so this is where we say, this is the closest that science gets to saying this is a fact. It does not change. We know it is how the universe works, is these laws. And so that's kind of where we go from hypothesis, which is a guess, but something a guess you can test. Theory, that we've tested it a bunch and we haven't found it to mess up, to law, where we've tested it in basically all situations it can be tested in, and all situations where it could apply, and it is true, and we've proven it's true there. Therefore, we call it a law. On occasion, theories may be adjusted, and on exceedingly rare occasions, laws may be adjusted. So again, science is not infallible. It's not that there are never mistakes made, but I want to emphasize that these are rare instances, and particularly with laws, it only happens if there's irrefutable evidence, meaning there's no other way to explain it, and that evidence alters the fundamental understanding of the world, meaning there is something that we've seen that says there is no way for this to work with our current law, and there's no way to say, oh, this was just an error in the measurement. Those are the only circumstances where a law or a theory are adjusted. So someone just saying, hey, this law doesn't make sense because here's something I thought up, or here's something I just did in 5 minutes in my room, that's not going to be irrefutable evidence that our fundamental understanding of the world is inaccurate. Now, that's not to say that that's not the start of going down a pathway where eventually that's robustly done and peer-reviewed and checked and all the possible things are ruled out. But anytime you see someone getting on the internet saying, here's something I just did in my room, or here's something I just thought up and it proves why such and such is wrong, that's not significant enough evidence. They're going to have to defend that and get more people to help them test it out and check their work and do all of that before we would overthrow a law or a theory. And so in other words, this is where we say something is true in science. Are we actually saying that it could never be proven inaccurate or that we know and that it won't ever change? No, but in general, these are our basic things. In physics, there's basically one or two major shifts in the last 500 years that have adjusted theories and laws, but otherwise we've been pretty consistent from that time, and things have built and just confirmed and further lent evidence to things that we already knew.